know.
My apologies.
Oh, no problem. So we'll talk about that a little bit too, because usually those are some of the number one questions, and then I'll open up questions. Absolutely happy to talk about anything that you would like to hear me talk about. So we'll take questions. So again, my name's Carl Beard. I have a PhD in engineering. I actually got all of my degrees at Texas A&M, right? Bachelor's, master's, and PhD. And I've been working in the business for over 30 years now. So I've done quite a number of things. I will make another pitch for Emerald College. So I'm gonna, you know, a little foreshadowing, but we're in my career with my family owning Alamos Textile Associates Lab. I was a 46-year-old, now 47-year-old company, does nuclear and environmental work across the nation. We work from coast to coast. And my wife, who was an AC associate's degree earner, went on to get her bachelor's in Texas Tech, is our president and CEO. We're officially a small business. I'm the COO. I take care of the operations. I handle the nuclear piece. She does all the financial back office, runs the business piece. But just another message that you're in a great place. Right? Great place, great start, can lead to magnificent things. So I want to encourage you on that path as well. I would tell you, I think you're on the right path. So but back to me a little bit. So I started out really interested in more in the physics space. So nuclear engineering is really a melding of mechanical engineering and physics, and specifically nuclear physics. And I really like physics. I liked engineering too, but I really wanted to be more of a physicist. And it was my father who actually gave me one piece of engineer or advice when I told him I wanted to be a nuclear physicist. He said, "Well, that's great, but you ought to be a nuclear engineer because you can do the same thing and they're going to pay you more." And he was absolutely right. And so I did that. So I ended up getting all my degrees in nuclear engineering. I did all my graduate work with Los Alamos National Laboratory. I actually started working at Los Alamos when I was a junior in college as a summer intern, right? So all of the laboratories have very active intern programs. Something that you ought to look into as you advance your studies. And then I did all of my graduate work in conjunction with Los Alamos, both my master's and my PhD, even though I actually was funded by the National Science Foundation. And then, lo and behold, I started my career at Los Alamos. So I went there, spent about 10 years there, where I was an active scientist. I did all kinds of different advanced nuclear power, high energy physics, really across the board. Got to do some fascinating stuff. I was in Los Alamos when the Cold War ended and the Berlin Wall fell. I actually published the first joint paper between a U.S. government scientist, nuclear scientist, and a Russian nuclear scientist. So if you go back and dig out nuclear science engineering, which is a publication of ANS from circa 1993, you can find that publication. So I got to go to Moscow a couple of times. And that's one message I would send is the nuclear industry is an international industry, and there's opportunities both to travel and to live across the world. And again, fast forward a little bit later, I spent a year in the United Kingdom working at Sellafield, which is their largest nuclear facility in the United Kingdom. But I have colleagues that I went to school with. I know that living in Hong Kong, United Kingdom, France is another big one. Many people spend a lot of time in France, big nuclear nation in terms of both power generation technology. So all kinds of opportunities to do some really fascinating things that you may not otherwise immediately think of, right? That it really does provide that international perspective and international opportunities to travel, even if you don't choose to go live in a different country. So, as I said, I spent about 10 years doing advanced engineering and physics. Left Los Alamos in the late 90s, went to the University of Texas at Austin, where I was a professor there for a few years, also the director of their trigger reactor and nuclear science center that they have down in Austin. Again, we were involved in all kinds of fun and interesting science. I left there in 2001 and I went to Pantex. So moved up here to Amarillo, ran their high explosive operations. And I always say there's a break point there. So sort of before Pantex, I actually used to do work, and after Pantex, I have been a manager. So I don't really do real work. Other people do work and I take credit for it. So but we managed the high explosive operations at Pantex. I became head of all of engineering at Pantex. And then went actually back to Los Alamos in 2006, where I managed all component operations at the laboratory, as well as some other cats and dogs. And then ultimately took over all the support services in Los Alamos, where about half the laboratory. So I about 4,000 employees, $1 billion worth of scope, and supported everything that went on. So spent a lot of time in New Mexico, a lot of time in Los Alamos. At that point, this is now, if you fast forward about 2014, my youngest daughter finally graduated college, and my wife and I decided we wanted to do something different. That's when I took the position to go over to the United Kingdom and to work on their new facilities, mostly which were in cleanup stage. Now, Sellafield is one of the most complicated nuclear facilities on the planet. 2 square miles, which by the way is less than what your campus is here. It was 4 nuclear reactors, full nuclear fuel reprocessing, nuclear fuel manufacturing, vitrification of all high-level waste processing, and they did a few other things. Oh, and by the way, they're also right on the Irish Sea. I mean, literally, their campus borders the beaches. So it's a very, very interesting, very intriguing place. It has a wonderful history. The British have been involved in nuclear all the way back with us. So some of the very early nuclear science discoveries were driven by British scientists such as Chadwick. They were very active during the war years, which they were partnering with us. They sent all their scientists over here and were with us at Los Alamos. And then they established their own capability following the war. So they've got a lot of history there. Great people to work with. We love living over there. We came back after a couple of years. I actually then took a job with Plaid. I moved back in Albuquerque, supported Sandia. And then when we bought the company a little over 2 years ago, we relocated back to Amarillo because that's where our family is. We brought all the headquarters operations here. So we operate out of the old Zachary building off of I-40 Bell. We do projects across the nation. So a little bit about Aladdin. I said we're a nuclear environmental firm. We do. Aladdin was born out of Los Alamos. That's hence the Los Alamos Technical Associates name. But we are a private company. We're not associated with the laboratory. And we have a long history in nuclear material processing, which is part of my expertise, given my history both with Pantex and Los Alamos and nuclear material handling, making things with it. And we also do environmental remediation. So we clean up sites across the nation. We're active here at Pantex. We're doing all kinds of installation of groundwater treatment systems for them. So if you drive past Pantex Highway 60, you look to the south and you see activities construction. That's LADA. You look to the north, we're actually installing pivot sprinkler systems for them to take their treated wastewater and use it for pivot irrigation instead of just injecting it back in the ground. And we're doing some treatment enhancement capabilities within perimeter. So we've got quite a bit going on at Advantix. Advantix has a sister plant called White 12 in Oak Ridge, Tennessee. That's where all the uranium components that go into the weapons are manufactured. It's also the only place in the nation that handles what I'll call bulk, highly enriched uranium. There's some spot other areas that deal with it, but mostly it's White 12. We LADA run all waste management, White 12, a little bit of solid waste. So we have a pretty strong footprint in the rich area. We just were one of the winners to take over the management operation of the waste isolation pilot plant, which is down in Carlsbad, New Mexico. That is the nation's only geological repository for nuclear waste. So it's a salt mine, roughly a mile down an assault repository where the nation disposes all of its transuranic defense waste. I can get into all kinds of what different wastes are, but I won't go into that right now. Give a question?
No,
Sorry.
no.
And then we work at Sandia, doing all kinds of engineering. We have contracts. We have defense contracts with the Air Force supporting nuclear weapons, but we also have a lot of Department of Defense taking care of environmental issues at military bases, all through here in the state of Texas and up in the Midwest and around the Great Lakes. As I said, we do everything from, we just finished dismantling the nuclear reactor up on the Morris Livermore campus, to building new things. We're actually up with a company who developed a technology to recycle asphalt shingles, scale that technology up and industrialize it. And we just started up their first plant, so they can fully recycle the asphalt shingles and sell off the subject components. So sort of all kinds of cats and dogs. And you know, you look at some of those species here and think, well, that doesn't sound very nuclear. But I would say that's one of the things that people miss about the nuclear talk, right? So one of the unique aspects of nuclear engineering is the interconnectivity of all the elements, right? So, you know, if you look at a nuclear power plant, you have the physics in the core, but the physics is intimately connected to the coolant. The coolant is intimately connected to the steam generation, which is intimately connected to the power generation, and then all of the safety systems. And so everything is connected. So if you pursue and you go down this path of engineering, what you get taught is this systematic thinking process around all the components of the system. It's not just about one thing. It's not just about the pump or the core or the control rod drives or whatever you might be looking at individually. Everything has to be analyzed collectively. And what you see now in our society is it's almost everything are these large, complex electromechanical systems with high levels of connectivity. So nuclear engineers come out with sort of a unique perspective and the natural tendency to look for all these connections and understand how subsystems affect both other subsystems as well as the overall system as a whole. And therefore, we end up doing all kinds of things that may have no nuclear component, but more of a systematic systems engineering required. As I said, so people I went to school with that literally got nuclear engineers degrees. You know, I know many who went into the space program, so the space is another high demand area. They worked on the space station, they worked on a space shuttle. Again, those are very similar systems. They're highly coupled, very independent, very interdependent systems, right? If you think about like a space vehicle that, you know, you have all the launch considerations, but then you have, you know, same thing. The reentry considerations are different. The during, you know, mission considerations are different. All those things have to be understood and related. So a lot of nuclear engineers around the space industry and the aerospace industry in general. So you know, in terms of I always, if you want to know what is your technical expertise, it would be a nuclear material processing, especially plutonium. I'm one of the really, you know, leading plutonium experts. Vast majority of my, you know, circa 80 publications are plutonium, as well as high energy physics and or high energy exploration physics. I should make it more specific, and then some on advanced power systems as well. So with that, that sort of gives you a snapshot of sort of where I've been and done. And again, I'm happy to answer any questions or more details and details. Let me talk then about the jobs, right? So what can nuclear engineers do? Now, the interesting thing is, as I told you, I've been in this business for 30 years, and for over 30 years, I have heard multiple times, why would you ever want to be a nuclear engineer? You'll never get a job. Believe it or not, I heard when I was probably either a freshman or a sophomore in college, why are you going to be a nuclear engineer? You're never going to be able to get a job. Well, 38 years later, I've never been without a job, right? And I will tell you, this is an actually honest truth. I do not know a single nuclear engineer that has ever gone a day without a job if they wanted it, right? We actually, our field has been perennially understaffed for the entire length of my career, right? So a lot of nuclear engineers came out in the 60s and 70s. The 3 Mile Island accident in '79 really you saw a dip, and then sort of the double whammy with Chernobyl in 1986. And there was this perception that nuclear power was dead, and therefore there was no need for nuclear engineers. And of course, neither is true. Nuclear power has never been dead, nor is it dead. And there's a much bigger need for nuclear engineers, way beyond nuclear power. In the nuclear power industry, honestly, although it's stalled out in this country, we've only built a few reactors, and really here more recent. It didn't stop anywhere else, right? So no other country stopped. This is sort of typical. We see things as a bubble sometimes. So I talked about the international aspects. At the time we were building no nuclear reactors, China was building nuclear reactors as fast as they could build. And hence my friend who lives in Hong Kong, right? So he went over there very early in his career and has been there ever since, supporting China. And now actually he works for the Hong Kong utility out there that's sort of overseeing their build. France has been pretty much at 100% nuclear capacity for decades, which means that basically all their electricity is nuclear except for hydro. So they run about 75% nuclear. They have a very integrated system of their nuclear power stations, as well as their nuclear fuel fabrication and reprocessing. So France has always been a very, very strong nuclear, and even in the United Kingdom. So the United Kingdom has 2 new generation stations actually being constructed even as we speak, and they will. The whole situation with the Russia, Ukraine is going to drive a lot of the Western nations over there even to a harder nuclear. Germany used to be strong nuclear. They backed out of that after Fukushima. They're now regretting that because they made them dependent upon Russian gas and oil, and that's, as they find out now, a really great place to be. So they're beginning to try to talk back, actually look at if they can restart some of their nuclear power stations shut down. So there's a lot of nuclear power stations out there. So we have 2 in Texas, Comanche Peak, just at southwest of Fort Worth, and South Texas plant, which is just south of Houston. And their nuclear power stations all over the country. So you might see the news, California was shutting down theirs, they just stopped. Now the Department of Energy just gave them $1 billion to keep the Alamos Canyon going. They did shut down a couple other ones, which were unfortunate. Some of the other ones up in the Northeast shut down, but almost all the plants, their lifetimes have been extended to try to keep them going. Number one, CO2 free power source. Right? Yeah, in fact, the only and it's always dangerous to say it's CO2 free because you still got to make concrete, which everything produces carbon dioxide somewhere in the production path. So even windmills, there's a lot of carbon dioxide that goes into actually manufacturing. It's the same thing with nuclear plants. They don't emit carbon dioxide emissions in the power production part, but when you're building them, they certainly have a carbon footprint. So just something to keep in mind. And true for any power source, whatever they tell you. But nuclear is the only power source we have that could replace all of the carbon power sources, right? Gas, coal, oil. So wind, solar, and hydro, it is physically impossible, right? So right now, nuclear is the only way if you really want to reduce carbon emissions worldwide. There's one option. It's nuclear. Now, whether or not people will realize that, we'll get there, we'll see. But believe it or not, one of my very first publications with a professor when I was at A&M. And at that time, I was actually charting CO2 emissions versus temperature and showing correlations. And he put that in his book that he was writing, talking about the need for nuclear, which back then it was a bigger debate than there is now. So nuclear power is growing. It's going to be there, but that's by far, honestly, sort of one of the smallest demand areas for engineers. Right. So when I was at University of Texas, almost all of my students actually went to satellite years. So I already mentioned the space industry, and the space industry is one of the largest demand for nuclear engineers, and that's because space. Most people don't think about this, but space is a high radiation environment. Once you get out of the atmosphere, you enter high radiation fields. So if you're going to design things that are going to go beyond the atmosphere, like satellites, it really helps to have people who understand radiation as well as engineering of complex electrical and mechanical systems. And guess who knows how to do that? I'm an engineer. So almost all my students at that time, because there was a big boom in satellite advancement production, and they really were in height back then. There's still a big demand from the same space industry. Obviously, as I'm sure as you see everything from SpaceX to all the satellite-driven internet, even now, the utilization of sort of the low Earth orbit and just the exo-atmospheric usage is very, very high, not likely to go down, and therefore they have the same need for this combination of experience, understanding radiation effects on materials, especially on electronics, and also just the design and manufacturing of complex electromechanical systems. In the microelectronics business, that's also a high demand area, again, because when you start getting into semiconductor manufacturing and the functioning of semiconductor and microelectronics, so both the manufacturing has a large, nuclear atomic physics component of how they manufacture those chips, and then how the chips function and can misfunction are highly dependent upon radiation fields and radiation interactions, including what's typically called single event upset. So a single, radiation interactions, whether it's a particle or whether it's electromagnetic radiation, can interrupt the functioning of any microelectronic chip. And therefore, when they design those chips, they have to develop redundancy to protect against those single level upsets, or else all your stuff will stop working all the time, because we all walk around in a natural radiation field that's everywhere. And if you can have a single event stop your phone from working, well, that's a problem. So they design around those redundancies, they test, they do experimentation. Again, what do they need? They need people to understand nuclear physics, nuclear radiation, and solid state matter interactions, and then the ability to couple that with range differences out their devices. Large demand there. And then the other sort of huge area is nuclear medicine. So a couple of my friends, when I went to school, they went on to actually go to medical school, and they specialized in nuclear medicine. So they got a bachelor's in nuclear engineering, went on and got MDs and specialized in nuclear medicine. Obviously, it's a huge field. I could talk for an hour just on all the different aspects, everything from isotope treatments where they inject isotopes in you, and then they tie it up with chemicals to concentrate a certain area, and then the radiation there kills the cells, typically cancer cells that you want to kill, to external radiation sources that they develop that where you're creating the radiation outside the body. It's like X-rays, but more powerful and more focused, again, to try to target and kill typically cancer cells that are growing. So it's a huge industry. Even on isotopes, so a lot of the imaging that they do externally is based on both injecting or imbibing radioactive sources. They're produce out certain particle and radiation characteristics that can be imaged outside the body, right? So all kinds of stuff. So you can be a doctor, you can be what's called health physics, which works at all the hospitals. Every single hospital has them. Actually, all the nuclear sites have them. And those people are responsible for helping protecting all the workers who have to work around these sources. Or you can be sort of the specialized pharmaceutical industries or specialized imaging industries who work around how do they either create these technologies to image things within the body or treat local things within the body, or so either develop or field and stuff. And so the medical industry, huge demand for nuclear trained. It's a large pool there. So that's sort of a quick snapshot. Again, I've known nuclear engineers that go on and do stuff that's way outside the nuclear arena. But once you have that engineering moniker, you have a lot of flexibility. I know people who are really ended up on the physics side, people who ended up on the engineering side. It really is that good meld of if those things are of interest to you, it's a really nice meld that allows you to market and sell yourself in many different ways when you're looking for a job. And like I said, it's if you're a new engineer, you're not going to go without a job if you want. So, all right. So there's my quick and fast spiel. But so what are you interested in? What questions can I answer of you? I'm willing to talk about anything. So yeah.
What's a piece of advice that you give to students going into the engineering?
Yeah. So for any, I would say try to make as many professional contacts as you possibly can. Right. So you put up the list of being as part of AIS. That's fantastic. If you get the opportunity to go, they have in essence student conferences you can go to. You can present papers. Another great thing to do is hone your communication skills. Right. So the number one thing that'll make you more marketable and more successful, past just being a good engineer or good at whatever you do, is have well honed communication skills. Right. Those skills transfer to every single job that you can possibly do. There is no job, even if you are going to work remotely on a computer and never see anybody. I will tell you how you word and fashion emails is critically important. You better hone your communication skills. And the best way to do that, honestly, is face to face, because face to face, you get that immediate feedback to understand how people are reacting to your words and how you say them. And then you can consciously apply the same techniques that you have written communications, or even like Zoom meetings or Teams meetings. Right? It's very, very important. But the professional contacts are one of the things that you have to go out and work at. Right? You have to find those venues like this. Professional societies is a great one, but it can be other societies to develop those professional contacts, and then you have to be willing there to go up, and again, this gets sort of back to communication, talk to people, right? Ask them about themselves. Everybody loves talking about themselves, right? So ask them about themselves, get their contact information. So I did a really weird thing back when I was in school, because believe it or not, email has sort of just been invented. And I kept an email list of everybody that I met, all the people I went to school with, and then I would meet other people, and I would always say, well, what's your email? And literally, believe it or not, back then, you had to have sort of your own workstation. You had to work in a place like the university you have an email address. So it wasn't very common, but it was just so valuable, because then I could reach out to people and I got to know people. And in fact, my list got so big, I had so many A&M people on it that I finally gave it to the university, because I don't have time to maintain this list, right? But I don't want to lose the list. But really, this has so many Aggies on it. You guys ought to just take it and maintain it, and they did actually. So being willing to go to these places, meet people, talk to them, get their contact information, ask them questions, right? Especially if it's a place you think you might like work, you say, do you have internships? How do you apply? Is there somebody? I mean, all kinds of things. The old adage of it's not what you know, it's who you know, isn't 100% correct, but it's still really, really important. I mean, those professional contacts. I will tell you, I got every single one of my jobs except for one, which was the very first one, and I just got really lucky because of who I knew. I knew people and they hired me, right? And then they hired me because of the interactions, because they knew me, they were exposed to me, right? As opposed to just blindly seeing a resume or something, trying to understand, trying to pick somebody out from a resume. And we hire people all the time. And I will always, if there's somebody we know through some way, that we have some kind of way to gauge that we think they'd be a good fit, always going to choose that person over somebody that we just don't know at all. And so those are sort of the two main things. And like I said, I think you're on the right track. And the American Nuclear Site has some immense things to help you out, as well as AC. Use all those things, right? So I've known a lot of students who, I can't find a job. Well, did you use your job placement system? Did you use your, and that's usually the problem. Again, those are nuclear engineers, but I have had other students that had some good things. So, great question.
At the company that you own, what kind of internships are available? Summer internships.
So we do. We typically have engineers, and we just have, and we don't have, because we're, I'll say small, so we have several hundred employees. We're not, when I say we're not, in our world, we're small. So I used to work for Fortune 400 companies. We had 18,000 employees, right? So, but so we don't have like hard requirements. So you must be a junior with a 3.0 grade point average, etc. So we typically hire engineers.
Is your students? Okay.
So we just had one senior level who finished his internship with high school for his master's. We have a lot of our engineering is done out of the Columbus, Ohio office. I didn't mention we have offices here, Los Alamos, New Mexico, Albuquerque, New Mexico, Columbus, Ohio, and Oak Ridge, Tennessee. Our Columbus office is about a mile from Ohio State University. So we get a number of Ohio State. I think we have two interns there right now, and the engineering. And then I actually have one environmental scientist. So we do hire quite a bit of environmental scientists. I have one environmental scientist actually in Oregon, because there's actually a landfill we're taking care of for the Air Force up there. I didn't have any local employees, so we actually were able to work out with an intern to get her some experience, at the same time take care of what we needed to do in terms of monitoring that site. So we consider anybody for internship, right? And in fact, I will say not just engineering. We talked a lot about getting communications or marketing interns. So we in our business, we have a constant cycle of proposing for work, right? So we have all kinds of opportunities, and we have to develop proposals. Those proposals, we always have, a strong technical side, of course, depending on how we're going to go technical execution. But depending upon the size of the client, we package those, it's readable and understandable form as possible. And so we have a specialized business development people who do that. But it's our workload is demanding. So, communications or marketing students that might have some skill, especially in graphics, page layout. You can start with very simple stuff and then get more involved as they can learn some of the technical side. We absolutely consider those people as well. That's honestly one of our busiest areas. Is our business development side of the house. And, getting those people who really understand how do you make things look pretty, right? The engineers will give you the how do you do it, and then it's okay. Now we gotta sell that and make it easily readable, look pretty, get some good pictures in there, good diagrams. A lot of times we have page limitations, so we got to figure out how to take 30 pages of technical jargon, give you 20 pages that actually tells you what we're going to do. So I would say we would consider, and we're flexible too, right? So we don't, again, because we're a family-owned business, we don't really have hard and fast rules. We just look for things that work now. We want to have meaningful experience for students, right? Like I was a student intern, and I would tell you, my very first semester or summer, I was just bored and stiff, and that's because I was an intern. It sounds like I didn't have security cards, couldn't do anything, but that was awful. It was just one of the worst experiences in my life being bored. So, so I'm a big stickler on that, right? Let's make sure we have meaningful work, interesting work for students to do. But if you have students that are interested, send them our way, because we absolutely consider anybody.
So would any of those, did you internship be, I mean, it was office?
Yes, especially the VD. We've done engineering out of here. The WT student worked out of here, and we had him support some of our projects with Advantix students. We got to go out and actually work. He actually red line drawings for us. We got to be able to do some real engineering. But most of my technical staff is in Ohio each year. But my wife actually she runs all of our PD stuff. We have resources both here and in Alabama. So any of the others, especially, this would actually be a preferred location. Actually, give it over.
So you said BD stuff.
Business development. Right, so that'd be the communications, marketing. Actually, although we have finance here, so we accounting, contracts, a little more on the legal side, getting pretty legal people that are interested in see how foreign industry contracts. Don't tell my contracting officer that. Engineering though too, certainly technical side. I would just have to make sure that we can assign meaningful work. It's a little easier when in Ohio I got an office of 20 engineers, and we pair them up and they get good guidance and mentoring. Here they either got to be paired with me or one of my higher level project managers that runs jobs. And then if we can do that, we can plug them in some of the jobs, and they can actually get some experience. And that's actually interesting when you get out in the field, either here or typically over in Los Alamos, where we have quite a bit of work. But I just have to be a little bit more careful because we don't have this same bandwidth of students in each area disciplines here that I do in Ohio or that we do in the other. So this is basically our corporate headquarters now. Technically still headquartered out of Albuquerque, but all of our upper level students.
Did you require the student that interface that
No, they actually didn't need to know. We work outside the fence, so we work outside and inside the fence. And so in this case, we just put in one of the jobs that goes outside the fence. And even a lot of our environmental projects, even if we work in secure areas, there's a number of us, I would say about 30 to 40% of our technical staff carries clearances, most of the kids. But for our environmental projects, even if we're working in secure areas, we usually bring a lot of unclear people to escort them. Because you're not going to get clearances. We have a lot of laborers, heavy equipment operators. I always say we are a doer company, right? So there's a lot of thinker companies. They'll give you a lot of advice. So we're a doer company. We go out and do things. And we run heavy equipment. We tear big buildings down. Usually they're contaminated, radiologically contaminated, or contaminated with other, I'll say unique hazards like beryllium, asbestos, etc. So you're not going to get a heavy equipment operator or laborer cleared. It's just not possible. So we expert them. So for sure to say that we would look to put them on a project that we could get them involved, and if they get them out in the field, either in a place that is non-secure, or that we can escalate. Other questions?
So you said you don't like having any requirements like Advantix would. So what would you be looking at for an intern? Like would be like ideal?
Well, first we're going to look at what your interests are. So what is your course of studies, or what are you looking to get out of the internship, right? So then the next thing we're going to look for is, can we match you with the scope of work we're doing? It would give you a meaningful experience, and hopefully provide us. Now, we don't really look for what I would call a monetary return from our interns because. I don't want to sound critical, but you're unlikely to get one. It's just, it's not that sometimes you get really great work, but it's just, you just have to be careful, you just don't know. So it's really, it's more of an educational opportunity for the intern. And all of our interns are paid, right? So we don't have unpaid internships, we pay anybody who works for us. And so, we want to make sure it works for you, right? So it's a matter of having the fit, right? Do we have somebody, do we have a scope of work that we can have you do based on where you are in your studies? And as you might imagine, there's a pretty steep curve, right? If you're an incoming freshman versus, someone who's sophomore year versus someone who's ending your sophomore year, it's a pretty wide disparity of what we might actually be able to assign you. And then we got to make sure we want to team you up with somebody who can give you enough time and help and guidance to make it so you feel like you've accomplished stuff, you learn stuff along the way. Of course, in the future you want to come back and work for us, that would be great. One of the great things about internships is they also do become employee pipelines in the future. But that would be the number one thing. We look at grade point averages per week, but I wouldn't discourage anybody, especially if you're early in your studies, of applying for that. Everybody's kind of people are trying to figure out what to do with getting a bad fit on the second year. And I've known a ton of people who got really smart people who got behind early on in their studies, and they're catching up. That's okay. So I wouldn't self-screen yourself before I'm telling you. It'd be more about the fit that we would have to look at versus anything else. But yeah, if anybody's interested, you can go to our website, www.latin.com. Talk to Dr. Hurd. He's got my email address. Send me your resume directly, whatever. Stop by our office. We've actually had people do that. And we're fine. Other questions?
Questions? Comments?
For our students that are interested in pursuing nuclear engineering, what give any recommendations on programs? Because my alma mater, Dr. Hurd may know. I don't even know if OU had a nuclear engineer.
At one time they did.
I don't
but
know if they do anymore.
No, and it was effectively done by 1990.
So
When they got rid of the AGM.
students interested in nuclear engineering, that obviously affects where they may want to try to transfer to a four-year university. Do you have any recommendations of where to look? Obviously, A&M.
Yeah, well, I'll just tell you it actually depends, right? So there's some unique things. So A&M has the largest nuclear engineering program in the country, and they have just tremendous resources. Like Texas is blessed. We have fantastic state university resources, right? So A&M has 2 nuclear reactors and more particle accelerators and cyclotron, and they're connected to NASA and all this. Tremendous. But there, the nuclear engineering department is unique and separate. So if you go to A&M, you're going to get, like I did, a nuclear engineering. Nothing wrong with that. It served me very well. But another thing I always tell students, when you get a degree, you get a brand. And that brand is going to say something about you, even if you don't say it. So I'm a PhD nuclear engineer, and people treat me like PhDs, right? Which carries its own brand, some good, some bad. And nuclear engineering carries a brand, right? But very fabulous nuclear engineering department, well connected everywhere in the nuclear industry. Now, University of Texas Austin also has a nuclear engineering program. It is part of mechanical engineering. So that's where I taught. That's where I worked. It's a option under mechanical engineering. So they have mechanical engineering degree, and then they have actually a number of options, materials, nuclear, thermal fluids, etc., that you can specialize in. And the benefit of that, you don't get nearly really the depth that A&M will give on the nuclear side, but you actually get an ability to represent yourself either as a mechanical engineer, a pure mechanical engineer, or basically a mechanical option. It allows you to market yourself a little bit more broad. So if you like more of the engineering as opposed to the hardcore physics, then that might be a way. And I would say the same thing, like if for whatever reason, going to an AM or UT, and there's a number, University of Mexico has a good nuclear program, University of Missouri, Georgia Tech, Purdue, MIT, Dr. Hurd knows them all too. I mean, but you could go to, a WT or a tech, get a mechanical engineer, pick up a physics minor, right? Pick up those courses in nuclear physics. You're going to get a lot of the same stuff. And again, then it's a matter of how you market, package yourself, going after those degrees. So there's options. If somebody says, "Oh, I really like this nuclear engineering stuff," but for whatever reason, A&M or UT or one of these others is not what you want to do out of your grasp. Look for one of these other options, and you can get pretty close. And I suspect then you write your resume right, you'll have no problems whatsoever. And then once you have that first job, you're golden. Right? Once you have that experience and say, "Hey, yeah, working in this industry, I'm there." So it really is. That's why I always tell people combination mechanical engineering, physics, nuclear physics, right? You get into too much theoretical physics or astrophysics, or again, that doesn't apply. It's sort of the basic nuclear physics stuff. Radiation effects with materials, radiation effects on people, those types of courses, and where you want to emphasize. And you compare physics with mechanical engineering, you have to be sure.
So is A&M's program under the college of engineering?
Yep. College engineering is separate. Well, it's a separate department. So it's separate. Like you go to A&M, there's a mechanical engineering department. There is a nuclear engineering department. Like a civil engineering department, and the electrical engineering department. I mean, so it stands alone. You go to UT, mechanical. Like you have to look for mechanical engineering because it's an option underneath the mechanical engineering department. Now at the graduate level at UT, they basically you become pure nuclear. So like it is, it's the whole thing is still administrative under mechanical engineering, but the whole graduate part is all nuclear. But at the undergraduate level, you would take 2 years of standard courses for all ME students. At your junior year, you could choose area of emphasis or option area or none. And then if you chose the nuclear option, there's a set series of courses during their junior and senior years that they would take. And the same thing for the other options. So it's just packaged with mechanical. And again, that has some advantages and disadvantages. And that's a number of universities do it that way. Especially when nuclear programs got smaller, a lot of them decided it wasn't worth trying to keep them independent because it's obviously more expensive. Any other questions? What kind of nuclear projects have I been involved in? Yeah. So I've been involved in the design of advanced nuclear systems. Early in my career, I worked a lot on accelerator-based systems, high energy accelerator, 800 MeV or more, where you can slam protons into high C targets, create neutron fields, and do things like get rid of nuclear waste. You can also do other things like with anything that really needs neutrons. At University of Texas, I developed the first test facility to be inserted in the nuclear reactor down there to test radiation damage to microelectronics. So Austin has a huge microelectronics community. So again, because anything that might go in space, especially, you really need to test and understand. So we developed experimental capabilities at the reactor there to be able to do those kinds of tests. Obviously, here at Advantix, I was involved in operations involving the assembly and disassembly of nuclear explosive devices, everything that goes into that. The Los Alamos on the plutonium side, there's all kinds of research, but so here's my wife always tells me, talk about this one, right? So I was responsible for the fabrication of heat sources that became the power sources for the Mars rover that's running around Mars. Right. So she said, "That's the coolest thing I've ever heard. How can you never talk about that?" So, oh, I forgot about that. So there you go. So now I can tell her I talked about that. Right. So the Mars rover is operating off of plutonium-238 heat sources. Actually, all deep space missions have to have a nuclear power source because they're too far from the sun. So you can't use solar, we gotta have nuclear, and they use isotopic generators. There are nuclear reactor sites to do that, but these are the power runs off of radioactive decay in 2238. So those sources are manufactured at Los Alamos, and that was done under my purview there. Cell fields, a lot of cleanup. I mean, I've done a lot of cleaning up old stuff. What most people don't think about is the nuclear industry is very young, right? So we're approaching about the 100th anniversary when they actually started discovering things, right? So actually the nuclear reaction, the neutron, I think was 1932, if I can remember my history. So they did make a lot of mistakes early on. They didn't know what this stuff was. They didn't know how to handle it well. So for instance, in the UK, they had stored a lot of their nuclear fuel and spent nuclear fuel. So fuel that had been a nuclear reactor came out, they put it in, you always put it in water because it has residual heat, so it involves cooling bonds. And outdoor cooling bonds. Well, that wasn't the best thing because over the years, you get all kinds of other crap in there and they get sort of this big radioactive sludge. So that was what we were doing over there. We were cleaning out a bunch of radioactive sludge out of these cooling ponds, as well as some of these older dry storage facilities. So anyways, that I mean, there's 30 years you work on a lot of different stuff. So I've worked on experimental stations, radiation sources, fusion. I used to do quite a bit on. Haven't done much fusion in the last 20 years. But fusion is that's its own topic. Well, both for nuclear power generation as well as fusion has actually other uses as a neutron source. Provide actually I didn't even mention the oil and gas industry. So if you ever heard of well logging, to understand the geologic formations as well. So when they drill the hole, they drop these radiation sources. They're actually typically fusion sources, DT, deuterium tritium sources, down. You shoot out neutrons into the geologic strata, and then there's a detector that detects what gets bounced back. And by those signatures, they can determine what the geologic strata is. So there's actually a big mine, Halliburton and Schlumberger, who both have huge operations down in Houston, are the world leaders in neutron well logging. I actually was offered a job by them coming out of college, which chose to go to Los Alamos as well. By the way, I was also offered a job down at NASA by a company called Crude Life Sciences that was responsible for all the human protection on the space station, which was just one design at the time. So again, another area where you see big demand because it coupled in the work I'd done on high energy physics particles and radiation fields. But the neutron well logging is also a big one. I did a little bit of that early in my career. I was trying to think of any other whiz bang stuff that might be interesting. I said next time I'll come back. I'll bring some show and tell. I got souvenirs from various things across my 30 years and pictures of nuclear facilities and stuff going on in nuclear facilities. So try to give you a little bit more entertaining brief than just sitting up here and talking about it.
Can you name exactly what that's?
Sorry.
Give a little technical title.
I don't know that name. Okay, yes. Yeah, yes. Oh, okay.
Yeah. The A is through 2015.
Okay, yes. Yeah, I've worked with so many people. We were trading names, and it's like you get to a certain age, and you're like, okay, I recognize that you gotta start narrowing down. Although I've had people in the UK say, "Oh, you worked at Los Alamos?" So I said, "Yeah." And they said, "Oh, and they always like, do you know?" And I'm thinking, Los Alamos is 12,000 employees, and then they say name. I'm like, "Yes, I did." It's a relatively small community, and you end up seeing, you get to work with a lot of the same people. So that's really nice. I had a class, so when I went to A&M, the overall department was about 200 people. Like I said, even at that students, even at that time, it was one of the largest in the U.S. Now it is the largest. So there was about 30 people in my undergraduate students in undergraduate class. And honestly, I've had some contact with almost all of them. and routinely sort of run into them in terms of like, gosh, it's just, it's just not a huge world. It's amazing. So, and some of those, like even when I was in England, one of the other guys that I was school with was working over there. We just happened to run into each other together. Any other questions? I think we're in the year hour, so I really appreciate you having me. I feel like you have come back. Other students or faculty that might have an interest in facilitating some students working with us.
And part of the greatest part of your coming here is your honorarium. And your honorarium, you have a choice of honorarium.
Wow.
And I've got an array of them. You have a choice between 2 caps. And then on top of that, you are presented a shirt from our Amarillo College Engineering Society. So I'll bring those up and let you make those choices. And then I don't know what you're probably operating on a very tight schedule, but if folks have time, please come back, get more pizza, drop by our speaker, and thank you. Thank you again.
Thank you. Excellent. Awesome.
And I think we've got another slide. That's not.
This will be just.
Okay, perfect.
Just for my curiosity, the liquid waste disposal outside of Carlsbad, I drilled a bunch of wells. So that's all disposed into the salt line?
Yeah, it's not liquid waste though, it's the solid transuranic waste that come from either the defense facilities or former nuclear. So like Los Alamos or Iowa, stuff.
Sure.
But yeah, so they drilled down some of them in the salt repository, that was a big mine.
Yeah.
And then they put everything in drums, certain compartments. It's all shipped down across bed, down the mine, and they just stack it up in what they call these panels. And then they leave it there and ultimately it's solved through the last.
I shared it with you.
Okay.
Thank you. That's great.
It's not liquid, it's solid.
They go into the mine.
Yeah, you got it.
Yes, that's exactly. So the mine that was mined, in fact, they're still mining panels for that purpose. And then